Good day, great girls. I hope you are doing well. This is Altin from Maths and Science series. We are located in Fosloras. We are offering physical sciences, mathematics, and life sciences. As I'm saying that we are located in Fosloras, Johannesburg. Fosloras, we are offering physical sciences, mathematics, and life sciences from grade 10 to grade 12. So we have services or a service whereby we are actually helping those who are upgrading their matric results, physical sciences and mathematics results. We have their service, or we have actually a program for them, those who are upgrading their matric results, specifically physical sciences and mathematics. Then their schedule is as follows. From 8 to 12 every day, we are having their classes, those who are upgrading their maths and physical sciences results. And now we are preparing for the upcoming examinations. For it's May and June. Yes, we are preparing that. So if you know someone who's upgrading their results, or who's looking or seeking for an organization or tutoring classes for helping them to pass with high marks, do not forget that you can refer us to those people. And we have those two programs for high school learners from grade 10 to 12, and for those who are upgrading their results. So if you want more information, make sure that you will actually I will leave our contact on this video, or on the blog of the video. So today I will take you to calculus. This is the first part of calculus. So make sure that you do what? You like, share and comment, and do not forget to hit on the notification bell so that you can be notified when we upload new lessons. So guys, please make sure that after watching this video, please, if you understood, if there's something that you understood, make sure that you do what? You comment on the comment section or comment platform saying thank you, so that you can see that what I am doing with you guys, you are really getting the gist of everything. Okay. Now, actually, when we talk, we are in differential calculus. We will use these weights or this weight a lot. Derivative. So a derivative is also known as the gradient. So if actually they say determine the gradient or determine the derivative, they are saying that you must find, or you must determine the gradient. So if they say determine the gradient, you must know they are also saying determine what? The derivative or the slope of the graph. So first principles, you will be asked in the exam to do what? To find or to determine the derivative using first principles. And it is always 5 marks if you have checked the past question papers. So this is the formula for first principles. It's f prime x, meaning the derivative or the gradient, equals f of x, but limit as h tends to 0, f of x plus h minus f of x over h. This is the formula that you use to determine the derivative or the gradient of the function or of the graph. All right. Now, why are we using, or why is the question saying that determine whatever of x or f of x using what? The first principles. Okay, suppose you have this formula. We know that this is a linear function, right? Or a straight line formula that represents the linear function. Okay, now, Elton, why are you actually telling us about this thing? Okay, we use first principle to prove if the given gradient is really the gradient. I don't know if you understand that. For example, we are given 3x plus 1. Now they say determine the graph, determine the gradient of y using first principles. What is it that we are really doing? We use first principle to prove if 3 is really the gradient. We know that this is what this is m, or this is a when we talk about what? The gradient. Now we use first principles to do what? To prove if 3 is really the gradient of y or of the graph y. I don't know if you guys understand that, but let me show you what is it that am I saying, or what is it that I'm talking about. Now let me say you have f of x equals 3x. Then they say find the derivative of f using first principles. There are other ways that you can use to find to find the derivative. But now they said they were specific that you must actually do what? You must find the derivative of f using first principles. It's always 5 marks. Make sure that you use it. So you use first principles to do what? To prove if the gradient is really 3. I don't know if you understand that. Now you write the formula. The first thing, you write the formula: f of x plus h minus f of x over h. This is the formula to do what? To find the derivative of any graph or of any function using this graph, the first principles. Okay, if you can pay attention to our denominator, we know that f of x is 3x, right? Now what about f of x plus h? Now this is what you will do. F of x plus h, meaning that where there's x in the graph f of x, you substitute or you add x. Yes, you add x rather than substituting, you add x. So it is 3, where there's x, I add h. Therefore, FOIL method, it will be 3x plus 3h. Now we have the value of f of x plus h. Simply, where there's x, you add h. Therefore, it will be 3x plus h. Then you do the FOIL method. Therefore, limit as h tends to 0, f of x plus h is that, which is 3x plus h minus f of x. What's the value of f of x? It's 3x. But you put it inside the brackets. Then over h. I don't know if you guys understand that. Then the next step, you will do what? You will get rid or eliminate what? This is 3h. Sorry. This is 3h minus 3x over h. Then after that, you can do what? You can simplify. Limit as h tends to 0, and this cancels that. You see that? 3h over h. Then you can see that even the h, they cancel. Now after cancelling, you don't show these things. Why? Because we're no longer having the h alphabet, meaning that this disappears as the as the denominator, as the numerator and the numerator cancelled. So our answer is 3. Now you have proven that 3 is really what? The derivative, or 3 is really the gradient. I don't know if you understand these guys, but the most important thing here, we use first principles to do it, to actually prove if the given gradient is really the gradient. I don't know if you guys understand that. But let us do the second example so that you can understand what we are doing here. Now let me say f of x is 2x plus 1. We know that this is what? This is the gradient, because this is a linear function, right? Now, since it is the gradient, we must prove if 2 is really the gradient. Therefore, what we will do is limit as h tends to 0. We don't have the value of f of x plus h, we only have f of x. Therefore, what's the value of f of x plus h? I said that where there's where there's x, you add h, meaning f of x plus h plus 2. Then FOIL method, which is 2x plus 2h plus 2. This is the value of f of x plus h, meaning that it will be 2x plus 2h minus 2 minus, what's the value of f of x? F of x, let me remove this. F of x becomes 2x plus 1 over h. Then you can get rid of the brackets. Then it is 2x plus 2h minus 2 minus 2x minus 1 over h, right? then actually this times this is this times, this times this is this times that is that. So these two, they cancel. I don't know if you can see that. And for limit as h tends to 0, now we are left with 2h. Now minus 2 minus 1 is minus 3 over h. Do you see this? Now these ones, they can't cancel like what we had on the previous example. Now what we're going to do now is that we're going to substitute this 0 where there's h. So when you substitute the 0, we don't write the limits again. So it will be 2 of 0, 2 into 0 minus 3 over 0. I don't know if you guys see this. So the answer here is going to be 0. I don't know if I've done this correctly, but now the approach is correct. Maybe the answer, or this is an error, but the approach is correct. It's not like maybe I've done something wrong here. The problem is here. Okay, but the approach is correct. Okay, let's do the second one. I hope you understand this thing, guys. All right. Now, let me say you are given f of x equals x squared. Now, they say find f of x, determine the derivative of x, of f using first principles. So you will write the formula f prime x limits as h tends to 0, f of x plus h minus f of x over h. Then what do you do next? You find f of x plus h, right? F of x plus h. Now you understand this, that where there's x, we add h squared. Therefore you simplify this thing. Simplify it. Then you do the following. You're going to have x squared plus 2xh plus h squared whenever you're doing the following method, right? Now that's the value of f of x plus h, meaning that we write limit as h tends to 0. Where there's f of x, you substitute that. It's x squared plus 2xh plus h squared minus f of x. F of x is x squared over h. Therefore, you eliminate what? The bracket. It's x squared plus 2xh plus h squared minus x squared over h. Therefore, we are left with limit. Now these are going to cancel. We are left with 2xh plus h squared over h. If you can look on our numerator, we have a common factor there. H is our common factor. So h, 2x plus h over h. Now these ones, they cancel. Since they cancel, it's not like we're going to make limit as h tends to 0 to disappear. No, it won't disappear because we do have what? The h there. 2x plus h. Now there's nothing we can do now. You take that 0, you substitute it on the h. It will be 2x plus 0. The answer is 2. Remember, when you substitute the 0, you make this thing to disappear. So this is our answer. So this is the first, this is the derivative using first principle, the derivative of f. Okay. So this is very, very, very important, people. Now, you are given f of x being 1 over x. Now, they say determine the derivative of f using first principles. F prime x limit as h tends to 0, f of x plus h minus f of x over h. Now, you find what? F of x plus h. Where there's x, you add h, right? Now we have the value of f of x plus h. which is 1 over x plus h minus f of x, which is 1 over x over h. I don't know if you can see these guys. Now you can do what you can simplify the numerators by cross multiplying. So this times this, it's x, minus this times that, x plus h over x, it's x plus h times, okay, it's x squared, this times this is x squared, this times this is xh. Therefore here it's x minus h over x squared plus xh. I don't know if you see this. Grade 10 mathematics, actually grade 9. So these they cancel, we are left with negative h. Then here you can say it's x squared plus xh. Now that becomes what? Our numerator, which is negative h x squared plus xh over the h, right? Yes, but mathematics doesn't allow us to have two division signs, meaning that we can write it like this, minus h x squared plus xh times 1 over h. Then this and that, they cancel. I don't know if you see this. This is mathematics. These are basics of mathematics, that we reciprocate the fraction that we are having as the numerator whenever we have two division symbols. So when this cancels, we're going to have negative 1 x squared plus xh. Right? Now, since we are here, there's nothing that we can do. We have what? We have the x as a common factor. Even if you can do that, like you're having something like this, x plus, not yes, plus h. There's nothing you can do. So this thing and that is one and the same thing. Rather, do what? You substitute the 0 where there's h. Or even if you want to do it like that, you can put the 0 here. Then it will be negative 1 x squared plus x0. Then the answer is negative 1 over x squared. So this is how you are writing this. I don't know if you guys understand this. So that's the answer of f, or the derivative of f, using first principles. Okay, now you can be asked to derive from first principles, or there is another way that you can use to derive if the instructions were not saying from first principles. Now you can use something known as a power rule, meaning that n multiplied by the coefficient, then subtract the n, that's the derivative. N multiplied by the coefficient, since the coefficient is 1, it will be n x n minus 1. So this is the derivative of x to the power n. For an example, let me say you are given x squared. They want you to derive this. Then it will be 2 multiplied by the coefficient. So here we have 1 times 2 is 2 minus 1, so the answer here is 2x. This is what? The derivative. I don't know if you guys understand that. If we have x cubed, 3 times the coefficient, it will be 3x, 3 minus 1, it will be 2. Now that's what? The derivative of x cubed. This is very, very important. You do this if they didn't tell you to do what? To derive using first principles. Now there are laws that you must follow. And let me say we have this. Before you can derive, make sure that you eliminate the brackets. We don't want to see the brackets. Make sure that you eliminate, because someone just take these two and multiply it with whatever that will be having here as the coefficient of the brackets, then they minus 1. They're doing the correct things, steps, but now in an incorrect expression. So before you can derive, make sure that you eliminate the brackets. Even here, before you can derive, make sure that you write this thing in what? In an exponential form as a1 over 2. Now from here, that is when you can do what? You can start deriving. And there, so if you want to derive here, make sure that whatever alphabet that you are deriving in respect to or with respect to, make sure that you do what? You do not allow it or you do not derive if it's yet what the denominator, meaning that it will be x to the power negative 2. Then from here is when you can do what? That's when you can start deriving. So I hope you understand this, but let me show you what I'm talking about. We have x squared. Here it's all about repeating what is inside the brackets. Then you do the FOIL method. You have x squared plus 2x plus 1. Now from this is when you can start doing what? Deriving. Because this to the power, exponent 2 multiplied by the coefficient of x, which is 2. Therefore it will be 2x 2 minus 1 plus we have 1 here. Therefore 1 times 2, it will give us 2. X to the power 1 minus 1, then plus the coefficient of a constant is always 0. Therefore, it will be 2x. 2 minus 1 is 1. Even if you don't write it, here it will be 2x, 0. Then plus 0, even if you don't write it down. Therefore, we have 2x plus 2, because any base to the power 0 is 1. Therefore, 2 times 1 gives us 2. So this is what the derivative of what we are having inside the brackets. I hope you guys are following. So you do this if they say derive, then they don't specify if you must use first principles or not. So if they didn't say from first principles or using first principles, don't use first principle. You can use power rule. Now let me say you have x squared, then they say derive. Remember, you don't derive as you are having this. Make sure that you eliminate it by writing what you have in an exponential form. We know that this is x to the power 1, therefore 1 times the coefficient, it's 1x. 1 minus 1, which is x to the power 0. The answer is 1. I hope you guys are actually getting the gist of this. Now, let me say you are given dy over dx. They say determine dy over dx. Dy over dx. Now this is what? Delta y over delta x. Meaning that we know that the delta in physical sciences is delta y over delta x. This is what? y2 minus y1, x2 minus x1. This is what? The gradient. And we know that the derivative is what? Is the gradient. Is the gradient. So you can be asked to do what? To determine dy over dx. It's also a derivative. Dy over dx of what? Let me say of 6x squared plus 3. Then this multiplied by this will give us 12x. So this is our derivative, because 2 times 6 is 12. 2 minus 1 is 1, and this becomes our derivative, because we know that the derivative of a constant is what? Is 0. Therefore, you write dy over dx is 12. I don't know if you guys understand this. So it's very, very important. Now let me say you have 1 over square root x cubed plus x squared plus 6x. They want what? The derivative. Before you can derive, make sure that you fix everything so that every term that you are dealing with is in its standard form for it to be derived. So here we can write 1 over x 3 over 2 plus x squared plus 6x. And we know that we must not let the alphabet that we are deriving with respect to be a denominator, meaning that we can still write this as negative x to the power negative 3 over 2 plus x squared plus 6x. Now everything, all the terms are actually on the standard form for them to be derived. Then it will be negative 3 over 2x, negative 3 over 2 minus 1, plus these terms, the 2, it will give us what? 2x plus 6. Then you can write this, you can punch it in your calculator. Since I don't have the calculator here, we just do it quickly. It will be negative 5 over 2. I'm not sure if this is correct. So negative 3 over 2, x to the power negative 5 over 2, plus 2x plus 6. That is the derivative, but you are not allowed to write it, to write the exponent after deriving. You are not allowed to make it to be a negative exponent. So you can still write it as negative 3 over negative 3 over 2x, 5 over exponent 5 over 2 plus 2x plus 6. So this is what? This is the derivative, or this is dy over dx of what we are having. So here, let me just fix it. It's 5 over 2. I hope now it's visible. So it's very important that after deriving, make sure that the exponent must not be negative. So make it to be a denominator so that it can become positive. So this is very, very important, guys. So you'll just use your textbook to make sure that you do what? You practice these things. But the most important thing, eliminate the brackets. For an example, the last one, let me say you have this, x squared plus square root x plus 6x. You can see that these two are in their standard form for them to be derived. But this one, it is not. So before you can derive, make sure that you fix everything so that it can be in its original form. Plus 6x. Now from this, then you can derive. So derive, then leave your answer maybe in the comment platform if you like, so that you can see that you are understanding what we are doing as maths and science service. Thank you, guys. Part 2 is coming, where we are going to draw the qubit functions. Thanks, guys.